That's not what I meant to do. I almost overslept because I woke up like literally 20 minutes before this. So I'm not sure how this goes. This was very spontaneous. I didn't come up with a I didn't plan this all too well, but I do have a lot of talking points that I kind of want to go over. All right, I think it's about time to start. I think we ought to start with our favorite graphics design program, MS Paint. So I think I'm gonna start off with text. Calibrite, disgusting. Come on, come on. Let me choose the font. There you go. Aha. So we want to make an matte plant. Probably make this bigger. Make this a bigger font, just a little bit. That works. So we have. So we got to lay out our constraints. First off, um, we're watering orchids, right? Um, so we have to know how they're. Oh wait, I should probably go into a little bit of background with this. My so I was talking to my dad one day about engineering and control systems and just what I was learning in college, and he's all like, "Well, with what you know, you could probably make me Or actually, no, we were talking. I was talking to him about I was scrolling through YouTube and I saw uh a video that I thought he'd be interested in. The PC I don't know if you've seen the PCB motor videos, but those are really cool. Like he makes an actual there's this channel. I don't remember. Let me see. Let me do the funny Googling real quick. Carl Bugeja. Yeah. Mans is doing God's work. But it's he basically made a brushless motor, but with PCV coils, all printed. I was showing him that video, and so like, oh, I was basically saying, oh, people like him are doing God's work, stuff like that, right? And actually, I forgot how it came. I think it now transitioned to what I was learning in class, and then I told, well, we have a few pumps at home. You can, you know, make a plant water, and I'm like, wait a second, I could probably do that. That shouldn't be too hard. So yeah, he wants to water multiple orchids, right? So we're gonna have to do a little bit of research on how orchids are watered. Another specification is that we have to water multiple plants. Now that I think about it, I should probably now that I think about it, I should probably Google what the engineering process is. Give me a sec real quick. Oh, I just realized I'm talking over no background music. Give me a second. There you go. If you've ever seen the scientific process, it's similar. Let me see. Hopefully. Oh, I don't want to copy and paste it real quick, but there is a process to this. There is a process to engineering. I might have gone out of order with coming up with my specifications before doing research, but I guess when you're out there, um your clients give you the specifications and you have to figure out the rest. So I don't know. We need to get some specifications down, right? We My dad only asked me to do this because he had a few pumps laying around, or a few water pumps laying around. So, so last for now, last but not least, it has to run automatically. Um, Trying to think if there's anything else we need to account for. we can make this more concise. Pumps automatically. Yep, looks good. So far this is like things that these are boxes that we have to check off. Right? So let's tackle this problem let's tackle these one at a time. So, just watering orchids. Let me use a different color for this. I'll use brown. Let's see. I'll move this down here. Oh, I think it was 26. Oh, I'm gonna have to make this section I'm gonna make the section pretty long. So, with the first problem, we don't need to. We just need to be underlined. So, I should probably make it black as well and make dividers instead. All right, now is where I'm gonna do my research on what the hell orchids need to survive. Let's see. Google, help me. All right, how to water orchids. Yes. No, but okay. The easiest way is to soak your orchid in a bowl of water once every week or two. Huh. When the moss dries out. So, okay. When soak the growing medium. All right, let's see what do other sites say. Okay, let's see. Stream water into the potting medium is thoroughly soaked. Give your plant a good soak in a bucket for a period of time. Place your plants outdoors during warm weather during periods of rain. the best place to water your plant is in the kitchen sink. Avoid overwatering, which leads to the demise of many, many orchids than underwatering. Constant wetness will cause the roots to rot. So maybe time-wise, I'm thinking watering on a weekly measure. Water your orchid early in the morning. Let's see. This site says allow the plant to drain for about 15 minutes. They should be placed so the pots do not stand in water. So if the plants have what's it? If these pots have drainage holes, then that makes my job easier because I can just drench them in water. Okay. So yeah. And growing media can be drenched, but we need to let the plant drain. Watering multiple orchids. I'll get to that issue later. Using pumps. That's another problem I have to consider. Okay. Here's here's the thing. When give me a second. I think I need to sneeze. No, never mind. Yeah, no. The feeling to sneeze has left me. My dad has already specified what pumps I'll be using. So it is time for me to Google them. I think I have one right here. There you go. Let's see. Let me Google this again. Oh, it's legit just Amazon's choice for pumps. I'm scrolling through reviews and apparently, the ground wire is not connected to anything. Lama. Okay, so it's a 12-volt pump. Okay, so let's see. Oh, 12 volt, and it uses 1.2 amps. That'll come in handy when what's it? Or that information only comes into play when I'm designing the external circuitry for this thing, or designing some circuitry for this thing. Let's see. The pumps. They're apparently they're designed for intermittent use. Hold up, let me make this the same size. There you go. What else do we see about this? The flow is 600 liters an hour. We'll convert that to liters per minute. That's 10 liters per minute. Wait, what's 10 divided by 6? Give me a second. I think I'd like to deal with in the seconds range. Okay, so bust on my calculator real quick. Six divided by 60 divided by 60. You get 0.667. So let's go with and should I don't know if I should convert that to gallons or not. No. Okay. I might use ounce because I'm American. So 5.6 fluid ounce per second. 5 fluid ounces. I'm actually not too sure about that. I'm not too sure what that means. The average coffee is like 12 ounces, right? That's what a cup. Is that what a cup is? Or is that 16 ounces? A cup is 8 ounces. Okay. So, it's 5 ounces. I'm trying to think about how much that is. I think maybe one pump could be enough. But we don't know. I haven't even come up with a way to deliver water yet. That was going to be answered in the multiple part. Let's see. Let's see, what else? There's no switch on this thing. So if power goes to it, it turns on. Hmm. All right. Unfortunately, I have not gone out of my way to test these motors yet, or to test these pumps yet. I will go do that later. So the thing that I've learned is or one thing I've learned is that you can split up a project into multiple sections. So like you have an electrical section, you have a programming section, and you have a mechanical section. In our case, the water delivery system is going to be our mechanical section. That's completely separate from the electrical section, which is how is our microcontroller going to interface with our motors? What motors are we using? How are we going to drive the motors? And then you have the programming section, which deals with only microcontrol, with just programming and coming up with software. And in my experience with, in working on a, multidisciplinary project like this, I mean, I could get 3 people to work on this so that we can get it done faster, but I only have myself, unfortunately. All right. Now for the fun part. What does it mean to have it run automatically? And I think you could have anticipated this issue from my thumbnail. So, I'm thinking of using a microcontroller, obviously. However, I have two, as of right now, I have 2 options to think of, or I have 2 options available to me. I have add the Raspberry Pi Zero versus I don't know if I should use an Arduino. What's it called? Is it called the Arduino Nano? Yeah. Actually, I think I can just make it go. I can just do that. Actually, I can do this. Oh no. Because what I'm gonna do is a comparison. Making making a table like this is gonna be tough. So let us make 2 tables. All right. So in favor of the Raspberry Pi, we have the fact that oh, okay. So let's list the pros. Actually, let me check which one I have. I think I have both on hand, but I'm going to have to make sure. Where did I put it? Oh. Where did I put it? Did I put it in my drawer? Aha, there you go. Raspberry Pi Zero W. Oh wow. They're selling on Amazon for $80. When they should only be 10. Jesus. I should probably stock up on these. I wanna buy like 10. Okay. So it has a 1 gigahertz single core CPU. We don't need to know about that. Mid HDMI port. Wireless LAN. Bluetooth. Bluetooth. That's what I'm interested in. Because I wasn't entirely sure if I wasn't entirely sure if it was able to connect to the internet. So, one of the positives is if I were to expand this project into the future, it could connect to the internet. That's good because we're going to be able to monitor our plants if we use sensors. The downside is, or another big thing is, I already have one. Let me take a look at it real quick. I also have an Arduino Uno right next to me. I'm assuming they have similar pinouts, so... Oh, there goes the Raspberry Pi. Okay, so what else can I say about it? So now for the cons. Oh yeah, another big thing. It's small. Now for the cons. Biggest thing for me is that I had no. I don't have much experience with Raspberry Pi. Let's see. I think that's the main downside to using a Raspberry Pi. Let me think. I think it actually might be stronger. Or I think it has better specs. But that's not too important for the scope of our project. Okay, so now for discussing talking points on the Arduino. Oh, god damn it. For one, they're stupid easy to use. I think I have a few on me, but they're not. They're one's for a different project, and one's for just testing, and just an Arduino that I have around. So not only are they stupid easy to use, I'm just gonna put that under, what's it? I do have experience. There you go. I have experience with Arduino. This can either be a con or a pro, but the connectors. See, the connectors, while they're good for getting rapid prototyping, you can just, plug them in and unplug them. Where they're not good is physical strength. You can just yank them out really quickly. You can just yank those wires out really quickly. They're not. The reason why I didn't list this as a factor on the Raspberry Pi is because I could solder in headers if I wanted to. So I could either solder headers, or I can just solder what's it? Or I can just solder the connections directly onto the Raspberry Pi. So one of the cons is I have one on hand. But they are cheap. Actually, let me check how much they are. All right, let's see. The nice thing about the Arduino Nano is that there are a lot of knockoffs. I can get one for $7, basically $7, one for $7 each. Oh, apparently they were $14 at one point. Uh, Elegoo Nano board. Three of them. Oh, this one's nice because the header pins haven't been soldered, so it's like I could use those. Um, yeah, I think the main deciding, or there's so what I'm thinking about now, the main question at hand is actually let me look at the Raspberry Pi Zero pin out, see what inputs and outputs I can use. Raspberry Pi Zero W, the pin out. Let's see. We did a plug G panel 4, 2, 3, 4, 5, 6. Oh wait. Yeah. How many ADCs are on there? I'm trying to find PWM MISC counting hole. All right, let me see if there's any ADC. Oh, that's a separate board. Let me see. Let's see. Drawing reduce schematics. Is this a Pi 2? Is this a 02W or a 0W? I think this is just 0. Yeah, I think this is just 0W. V1.1. Okay. Come on. Come on. Get back in the back. I am very leaning full. I really want to use the Raspberry Pi so that I get, you know, more experience with it. But I don't know if I'm even going to finish the project if I use the Raspberry Pi because I don't know too much about it. Wait a second. There is no Wi-Fi Ethernet connection available on the board. Well then. I thought that was going to be the main thing about it. But wait, this is Raspberry Pi 0. The 0W might be different. I don't know what wireless LAN is. Let me Google this. All it's telling me is it's just wireless LAN. I think that means that I'm only going to be able to access it if I'm on the local network. So just same as any other Raspberry Pi. But let me check. Yep, wireless LAN. Okay, so it's the same as regular Raspberry Pi. So it can't connect to the internet, but it can connect to LAN. Oh, what the hell? There you go. What might come into play is oh, come on. Come on. Big pro is that Arduinos have ADC pins. So I was thinking maybe I might need to add sensors to I might need to add sensors to the thing. And what are the sensors? Have an analog output. Well, only the Arduino is going to be able to use them, because I think they have, analog to digital PID. They have analog to digital converters on board. So that makes my life easier. Take a look. Now, another part of that segues nicely into my next section. Should we run this open loop or closed loop? So with watering plants, right? You can probably just get away with watering it, and set interval, or you have a lot of leeway, so to speak. It's not like you're dealing with like milliliters of tolerance, what I'm thinking, my approach right now, I'm thinking to just drench all of the soil when it's dry. We're not timing it once. I don't want to time it once a week, because what if soil gets dry before the week starts? Then the plant's not going to get enough water. So I want to add moisture sensors. Let's see. What does Amazon have? Oh wow, this is perfect. 10 soil moisture sensors. You just sell it like that? Oh God, just like that. There's even a kit that you can use to make exactly what I'm doing, but on a smaller scale. So it looks like on the Raspberry Pi, we need an analog to digital converter. So, oh wait, let me. Oh, yes, I can just add it down here. Because I could, develop an app for it later, or I can develop a GUI for it later. Oh, Smalton, I was so busy talking that I didn't even realize you were there. Hello. Hello, Smalton. How was your day? I didn't even notice. My bad. Did I see tickets open? Not too sure what you mean by that, but I actually do, but okay. So now, we need to talk about sensors. Or if we need them at all. So to recap, I'm trying to make an automatic plant waterer. These are my specifications. And so now I'm just breaking down each specification and doing research. And so now we have to break this down into sensors versus timing. We're gonna need a humidity sensor then, huh? Here's the thing. We might want to. We might want to use it. We might want to use a humidity. We might want to use a moisture sensor. But we really don't have to. So I guess now the crux of the issue is going to be, is running an open loop more important? Or no, is being able to connect to the internet more important? Or is being able to use sensors more important? Sensors. I really don't like the idea of running. Are you running on a timer or automatically? Well, running on a timer is automatic. What you mean is either open loop or closed loop. So What I mean by open loop is when it receives when the microcontroller receives data, the user input, which is you know, when to water the plant, it just operates it. There's no feedback going back into the system. Closed loop means that there is a loop of data going on with there's feedback involved. So I was just explaining if there was anybody in chat who didn't know what I meant by open and closed loop. So now comes the crux of the issue, or now comes a point where I need to get my priorities, where I need to consult with the what's the word? Consult with the client to determine further specifications. Now that I've done all this research, I also need to ask them for their experience with watering orchids. Another thing to keep into account is we want to minimize water use as much as possible because nobody likes wasting water. I might continue this series. I think I like this series. I might continue on with it. But I've talked about this project for an hour now. Oh, wow. Without any hydration breaks either. Let me go do that right now. All right. Hydrated. So, see, I looked up the engineering design process. You were supposed to do your research before you come up with your specifications. But, I mean, if you're trying to solve a problem, most of the time you're given constraints. So I guess I kind of did this a little bit backwards. But I guess when you do your research, you come up with more, or you come up with more constraints. So this section means, where is it? This section means that I have to I'm gonna have to design some external drivers for this pump. Because the Arduino can't provide 12 amps. Or the pot. So, for the scope of this, I honestly think that I think that using the Arduino might be better, simply because of the fact that we have access to ADC pins. But let me check to see how much let me see how many pins the Arduino has. Let me see how many analog pins it has. There are 8 ADC pins, which might be good enough. So yeah, I'm leaning heavily towards the Arduino Nano. Actually, I have an Arduino Uno next to me. This only has 6 analog ports. So I'm leaning very heavily towards an Arduino Nano. But I still haven't made a final decision. For that, I'm going to have to... I want to come up... So my cycle is going to be... do research, come up with specifications, design, and then do more research. If I need Wi-Fi, you might want to get an ESP8266. I have no idea what that is, but let me Google that. It's a low-cost Wi-Fi microchip with built-in TCP/IP networking software. Huh. Here's the thing, though. I'm worried about security now. Oh wait. Oh, it's legit just a tiny microcontroller board. This is something that I don't. This is something that I'm gonna have to look into. Let's see. Okay, so I don't have to worry about security. And I can just wire. There is or there is a development board with the ESP8266 on it. The only reason why I want to connect to the internet is because I might want to make an app for it. I might. But I don't know how easily it is to hack. Yeah. I'm gonna have to Google. Let's see. So. Okay, let's see. There is a vulnerability that enables attackers within radio range to cause a DDoS attack against connected IoT devices. So adding wireless or adding internet connection is a nice bonus, but I don't think we need it. I think the main thing is to make this as easy for me as possible. Um, I want to use something with a lot of ADC pins, analog digital converter pins. Yeah, I can make it better, but for now, I just need to get it to work. So questions I have are questions I'm going to ask my dad after stream. Um so I saw what the internet recommends me to do to water the orchids, but how does he do it? Number 1. Number 2, um what's it? I forgot there was something. Oh, does he want internet? Does he want to connect to the internet? And number 3, well, there was something. There was another thing I had to. When do you want to water the orchids? Pretty important. I. Oh, this is very important. Indoors or outdoors? When do we want to water them? I don't think it's as important because it's weekly. But it's checking around weekly. Indoors or outdoors? That's probably the most important aspect, or one of the most important aspects. Because if it's outdoors, then I'm gonna have to wire everything and plan everything for outdoors. But if it's indoors, then we're gonna have to. This pump is really big. Oh, the timing of the watering is important. From my knowledge, from my research, it doesn't seem to be too important. As long as you soak it and let it drain, you should be fine. That's from my research though. That's not from, experience. There was another question that I had to ask. Well, I mean, we don't really need that complicated of an external driver. We just need a transistor. No? Um I'm gonna go back to work and have fun. Okay. See you, Smolton. I think I was gonna end the stream right now too, because I don't think I can go any further than this. I'm gonna need more information. Yep. That's gonna be it. See y'all next week. No. Tomorrow I have stream. I have collab stream with Rion Akahoshi. Yes. So catch me there. Or I'll be there. I'll stream tomorrow. I'll catch y'all there. See you.